Here's problem 11:16. A solid sphere, spherical shell, solid cylinder, and cylindrical shell all have the same mass m and radius r. If they are released from rest at the same elevation and roll without slipping, which reaches the bottom of an inclined plane first? So they're all going to be released from rest, so we can either use dynamics or energy to solve this problem. Now if we look at these four objects, based on their moment of inertia, we have a solid sphere, and the moment of inertia of a solid sphere is 2/5 mr squared. We have a spherical shell, and the moment of inertia of a spherical shell is 2/3 mr squared. This is a 5 up here for the sphere. For a solid cylinder, moment of inertia of a cylinder is 1/2 mr squared. And then for a cylindrical shell, in other words known as a hoop, the moment of inertia is mr squared. So those are our four moment of inertias. And then previously we found that in general the linear acceleration of these objects going down the incline will be equal to g sine theta over 1 plus the moment of inertia divided by mr squared. So that is going to be our formula in general. So if we look at the sphere, this acceleration is g sine theta over 1 plus, and then we'll have 2/5. So it'll be 1 over 7/5 or 5/7 g sine theta. For a shell, moment of inertia will be g sine theta over 1 plus 2/3, which would be 1 over 5/3, which would be 3/5 g sine theta. For the cylinder, acceleration will be g sine theta over 1 plus 1/2, which would be 1 over 3/2 or 2/3 g sine theta. And then for the hoop or the cylindrical shell, it will be g sine theta over 1 plus 1, which will be 1/2 g sine theta. So these will be the accelerations of each of these objects going down the incline. So in terms of g sine theta, this first one is going to be 0.71 g sine theta. Next one is going to be 0.6 g sine theta. Next one will be 0.67 g sine theta. And the last one will be 0.5 g sine theta. So our largest one in terms of acceleration is the first one, the sphere. So that will have the largest linear acceleration going down the incline, all of them starting from rest. So in general, our displacement down the incline would be equal to our initial velocity times time plus 1/2 acceleration times time squared. With the initial velocity being 0, that means it all goes as the acceleration. All these displacements being the same, the one that has the largest acceleration will have the smallest time, and hence the moment of inertia for the sphere will have the shortest time. In other words, as the acceleration goes up, the time will go down, given that they all are going to have the same displacement. So that means that the sphere will win the race. So that's our answer. The sphere will reach the bottom first.